Welcome to Inspiro's presentation of Music of the Spheres. I wanted to take this moment before we begin to give you a little background on our distinguished guest this evening. We are so proud to have Dr. Hamanowicz, a researcher at the Space Telescope Science Institute. Her focus is mostly on dust depletion, and she just had a promotion, and so we're so very proud of her. I know you're just going to love listening to her talk about the cosmos. She is also an avid choral singer, so the choral geeks in the audience will love that as well. And she lives in Washington, D.C. with her husband and Rescue Lab Gidget. On a personal note, I would like to say that one of the fantastic benefits of our preparation for tonight's performance has been listening with childlike fascination as she has spoken so poetically about the science and the wonder of our cosmos. Inspiro's focus since its inception has been to inspire our audiences through choral music, and my hope is that you will be truly inspired by what you experience this evening. I now present Music of the Spheres. Looking up in the skies is one of the most human and beautiful things that we do on Earth. It is also usually a solitary act by one person. I grew up on a farm in Southwest Ohio in the middle of a cornfield, really in the middle of nowhere. There was no light pollution like we have in Northern Virginia. Thank you for that. My brother Ben and my sister Wendy and I would lay out in the middle of our field, of our yard, and look up for shooting stars. We knew where the Big Dipper was in Orion's belt, and we would be able to trace the sun all day long from sunrise to sunset. I didn't know how much I longed for that space until I was on a vacation a few years ago. It was in a moment that I looked up and saw millions of stars that I had been missing. It happened to be at the same time as the first images from the Webb Telescope started to be published in the news. As you will discover tonight, we have only begun our journey of discovery. The music that you will hear live tonight was the musical soundtrack for that personal awakening of my soul, and I hope that it sparks something inside of you as well. At this point, I'm excited to introduce you to Dr. Hamanowicz. From the very beginning, from the very early on,
started to look forward, we also looked up. Among the stars, we searched for answers for the questions that were plaguing our minds. We put heroes and gods among the planets, on the spheres up above. We were telling stories about what we see every day, about the changing seasons, about the movements of the skies. But very soon those stories were not good enough. We started to yearn for more and more knowledge and understanding of the world around us. Thanks to such giants like Galileo Galilei, Nicolaus Copernicus, Isaac Newton, and those who followed them, we started to understand our place in space. We started to understand where we are, what we are. We understood also very quickly that we are not one and only, but we are one of many. And the stars we can see up in the night sky are just the beginning of the gigantic, enormous universe. And up to today, after all of those centuries of discovery, of development of scientific methods, of technology, today when we arrive at the age when we are sending satellites and telescopes out into space, and we are considering doing that and placing them on the moon and other places, when we look up in the night on the sky, we actually ask the same questions that our ancestors did those thousands of years ago. We still want to know where we come from, what is our destiny, where are we going to, and also what is the meaning of life, and not least, are we alone?
Do not go gentle into that good night. O day should burn and brave at close of day. Rage, rage against the dying of the light. Rage, rage against the dying, dying of the light.
it's hard to believe that it's over 2 years now since the events we just rewatched happened. I have to say that just looking at all of this launch sequence and all of the elements of placing James Webb on the orbit still brings tears to my eyes. It's an absolute wonder what thanks to technology we can do. And the fact that it's there up there becomes part of our reality. And the images, like this one, which was one of the very first images we ever saw from this telescope, now make their way to the desktop of our computers and our phones. And we're starting to make it just our reality. But when we think about it a little deeper, apart from actual wonder and beauty of the images like this one, you might be asking questions what astronomers actually see, why taking a picture of those galaxies actually have a meaning. Pity that we do not have an astronomer with us tonight to tell us exactly what astronomers do with that. But yes, I'm going to tell you a little bit about what we scientists actually see when we are looking at images like that, and walk you through a little bit of those elements. So let's first start by looking at the very center of this image, this blue white light on those very bright objects. This is the cluster of galaxies, one of the most massive objects in the universe as we know it. In fact, there are several hundred galaxies in this cluster alone, placed much closer to each other than any galaxy there is next to our Milky Way. So we cannot really imagine what it is to be in the middle of a cluster of galaxies like that. Because they are so massive, they cause the light to bend around it. The gravity, as Albert Einstein told us, has this very interesting feature. When it passes next to something very massive, it bends its path. When we want to think about it in our everyday terms, it's very similar to using the magnifying glass or a lens to make something which is very far away or very faint much more visible and bigger to our eyes. That's exactly what this cluster of galaxies, many like it, is doing. It is sort of a cosmic telescope. We even sometimes call those objects Einstein's telescopes. And this thing which it's doing, it's called gravitational lensing. And this is the very first reason why we pointed James Webb exactly to that image. Because not only we can see the wonderful galaxies which are in this cluster, but especially it's magnifying the objects lying very far, far away, back behind the cluster. And without it, we probably wouldn't be able to see them, even with such a powerful telescope like James Webb. So where are those, the furthest, the faintest, the earliest galaxies in the universe? Because let's remember, the further we look, the further in time we are also looking. So if you squint your eyes a little and find the smallest, the reddest, the faintest objects on this image, these are the first galaxies in the universe. And that's why this image is so unique, because we can take a look at the very first stars that are being born, the very first galaxies, just as they were being formed in the early universe. But the fact that we are looking at the gravitational lens also adds another layer of interesting effects. If you ever have seen your reflection in a mirror which was a little bent, you could see that part of your body would be looking very funny, very thin, very big, very white, and you would not see your natural reflection. That happens when a mirror or a lens is not perfectly symmetrical. And of course, the cluster of galaxies is not going to be perfectly symmetrical like the mirror of the telescope or the lens in a magnifying glass. And thanks to that, it also distorts some of the images. We actually like that. So if you look again and see any weirdly looking object, arcs, elongated shapes, these are also galaxies, but they are not like that. They are just being distorted by those imperfections in the gravitational lens. Why do we like that? Well, whenever there are imperfections, that means that part of the galaxy will be more magnified than the others. And sometimes even a single star can be magnified enough so that we can see it as just a single object. And we have a star like that on one of those images. And thanks to that, not only we can see the further galaxies, but also study single stars within them. The very first stars are being born in those very first galaxies which are being born. So these are only two examples. And in fact, on this image alone, We have more than 200 scientific articles published already about the science being discovered from this single image alone. And how many images James Webb is producing daily, and how many of them produce another discoveries, and we are just on the second year of operation. We have many, many more to come, and all of those incredible wonders of cosmos to discover. Those very deep, very dense clouds of gas, something very, very special is happening. Hidden from our sight, deep in the cocoons of gas and dust, the new stars are being formed. Actually, those beautiful nebulae, which we often see as being the objects of interest of our space telescopes, like this one, are cosmic nurseries. So if you look at this image and you found the most dense, the most darkest clouds of gas, it's exactly when the new stars are being formed. We call them protostars. They are not yet ready to shine on their own. They are sitting even for millions of years in those cocoons, gathering more material, growing in mass. Eventually, when there is enough matter on this protostar. It's dense and hot enough in its core to start one of the most energetic events in the universe as a whole. Hydrogen starts to collide and create helium, releasing immense amount of energy, and stars is being born. Stars start to shine. In fact, the power of the photons being emitted from this thermonuclear activity, that's what exactly is happening in the center of the stars. The power of photons is so powerful that it blows away the material, the cocoon in which the stars were being formed. It doesn't have to be obscured anymore, it's ready to shine. In fact, some of the stars which we are seeing on this image are exactly the ones which form in this very nebula. But the star does not emerge alone from this cocoon of gas from which it's being born. It comes with the already formed planetary system. In fact, almost every second star in the universe will have at least one planet orbiting it. And those planets, just as in our solar system, can vary in size and in shapes and basically in any property you can think of. But some might be possible to harbor new life. think about the universe, we usually think about it as being static, as being unmoving. And in the first glimpse, actually, that's what it seems like, but in fact, there's no more dynamic and crazy place than the universe. Unfortunately, the scales on which those changes are happening are incomprehensible for us humans. Not only they are longer than our usual lives, generations, they are longer than the scales of which we know from geological times as well. The millions or billions of years, that's how much it takes for some stars to live through their lives, some galaxies to live through their lives. But make no mistakes. The universe is a dynamic place, and one of the examples of this dynamic behavior is what we are seeing right now on the screen, which is dance of galaxies. For gravity is a force which brings things together. And not unlike lovers, two galaxies can come very close to each other and start this very interesting dance. It can take millions of years. They're gonna be coming together, they're gonna be coming apart, they're gonna be coming closer and closer, drawn by this wonderful attraction of gravity. In the process, there's a lot of happening. Streams of gas and even stars are being thrown away from each of the galaxies in those wonderful and incredible events, as we just saw on the simulation up here. And finally, eventually, this dance comes to an end. Two galaxies meet each other, they merge, and they become one even bigger galaxy. However, there's a price to pay for being together. For through all of these violent ejections of gas while they were dancing, there's no more gas left when they are together merged into one object. And when there's no gas, there are no new stars. And if there are no new stars, the galaxy is slowly dying. is a very special, special science because our telescopes are time machines. I mentioned that a little bit earlier, but because of the finite speed of light, whenever we look at some objects which are very, very far away, we are actually looking back in time. Let's think about it for 1 second. So, light takes time to travel from one place to another, and every day we don't really notice that because those distances are small for the enormous speed which light takes. But the moon, as we see it, is about 1 to 2 seconds old. So every time we look at the moon, we see it as it was those 2 seconds ago. It's 8 minutes for the sun. So that's why even when we have some big ejection of matter on the sun, it takes a moment before we actually notice that on Earth. This distance grows and grows, and even in our solar system, we are starting talking about hours or even days. The nearest star is 4 years away, 4 light years away. So it takes 4 years for the light to travel. And we are talking about our galaxy, we are starting to talk about thousands of years, millions, billions. So the furthest we go, the furthest in the cosmos we look, the furthest in time we look. And that's one of the reasons why we built James Webb Telescope, because we really wanted to find those faintest objects, which most likely are the furthest ones. And also that means that they are the earliest, the very first galaxies that we can ever observe. So yes, when you again look at the night sky one day, think about it, that what you're seeing might not anymore be there. Like some of the stars may have already exploded, and some others may just be born. about at the very beginning of this concert about it's over 2 years past since James was being launched and how much we are enjoying these wonderful discoveries. I'm very privileged and very happy to be working with James Webb and Hubble Space Telescopes every day. As you can see, I even have a James Webb pin here with me tonight. But astronomers are dreamers, and it's not like we can sit down and be now relaxed and be now, okay, now we succeeded, we have James Webb up there, we're gonna do nothing. Absolutely not. We are thinking what we're gonna do next. And actually, this is not a very unusual thing. When over 30 years ago, Hubble Space Telescope was launched, the moment it sat on the orbit, we started planning for James Webb. Indeed, it took that long to actually plan and build the telescope. So now it's only natural that we are thinking about what's next. Why does it take so much time? Where the wonderful discoveries, reaching for what's unknown, requires the development of science and technology, which we might not even know right now. And the next generation of telescopes, which we like to call the next generation of Hubble 2.0, is what we are watching right now here, Habitable Worlds Observatory. The main goal of this telescope is already in its name. HWO, or Hubble Worlds for short, will be tasked with one single task: find second Earth. Even with Hubble, even with Webb, even with wonderful telescopes we have and we are building right now, we still cannot reach to those new, different worlds. We're discovering hundreds of them, but we cannot characterize them. And with the power of the bigger, stronger telescope, with the power of new technologies, we might finally find another planet which looks just like Earth. So now astronomers are sitting around and trying to ask the question, what do we need? What do we need to find a planet like Earth around a star very, very far away? So stay tuned, and maybe in the next few decades we're going to see this another wonderful telescope, and maybe another one's following it.
lights for me so you could maybe see me. There we go. Yeah, yes, this is not a complaint. We have come to the end of our concert. We have one more piece. I'm much shorter than. So I just wanted to thank everybody here. We had several soloists, and I didn't really get to show off and let them bow because during the concert we kept it moving. So if I could have all of my soloists, and if you want to applaud, soloists, could you take a bow? And that wonderful sound that you just heard was a vibraphone that was being bowed by two percussionists. If I could have them bow, they may have left. That's it. Yeah. And last but not least, I'd like to just one more time bring Dr. Hamanowicz up, and I'd like for you to take a bow.